click a photograph, it generates a image. If I want to model this entire process, so I have a fixed way of modeling. What I say, my measured image or the saved image, whatever, there is a difference between what you measure and what you save and what you see. So I ignore all this. What you measure, what falls on the sensor, what you save and what you see. When it is displayed through whatever the display tools. So all are different. But I ignore all this and say that what is measured is what you are seeing. How do I model this? There is optics. There is a light coming from which is integrated during the shutter speed of the camera and falls on that small area of a sensor, which is saved as one pixel. Isn't it? So when you start doing this, I mean that whatever if this is the area, this area gets back to 2 mm by 2 mm sensor, either the CMOS sensor or the older sensor. Most of the cameras now they have a CMOS sensor. Yes or no? So most of the cameras now, so it is 2 mm by 2 mm sensor. The entire scene or the area gets back to that 2 mm by 2 mm sensor. Depending on that, how much is one physical area gets back to 1 pixel. You know. So how do I model this? So I have a clean measurement model.
Audio video sync, but self delete.
Some system matrix A into F, which is actually the 2 input.
लैपटॉप iPad charge
plus some meter,
केबल तो बच बड़ा
which is an option. These are called. This G equal to HF plus theta does not depend on one particular image. This entire thing is a measurement model for a camera. Similarly, for example, you are measuring something or you are doing something, any sampling of physical things happening, when it generates a device, gets associated with a very objective way of defining it, which are called the class of generative models. So when I have a class of generative models, then there is a very clean way of handling the generative models. Because it's objective, I have a clean way of handling the generative models. How do we do it? Have you heard about MLE? Maximum likelihood estimator or estimation. And one more is what is called a MAP. MAP is a maximum or posteriori estimation. So if you don't know this, please, I've talked about this, probably I have derived these two. What is the relation between MLE and MAP for logistic regression in the MLE? When the MLE is equivalent to MAP, when it is not. So please go through that, so that whenever I started.
Yes, ma'am.
Yes.
Ma'am, slides forward madaka this button, reverse madaka that. Is ಇನ್ನೊಂದು ಬರ್ತದೆ.
Okay.
Annotation.
Annotation ಇದೆ.
Colors are there.
Okay.
ನೀವು ಬರೀರಿ ಆಮೇಲೆ ಅಕಸ್ಮಾತ್ ಇರೇಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಯು ನೀಡ್ ಟು ಯೂಸ್ ದಿಸ್. ಇರೇಸ್.
Okay.
Hello. Just check with them. Am I audible? Yeah, for you it may be slightly artificial because I may not move the way usually I move in the class, and that's okay. So just check with them, are they able to check with them? Hello? It's fine, okay. So welcome to the class on the course on Gen AI. Now the course structure that we have decided is 201. Initially we thought it's 102, but later we realized there is quite a bit of theory we need to cover, then we made it 201. So you'll have 2 classes per week, 1 class of 2 hours where I'll be teaching theory, and 1 lab, so we'll be doing the activities and the assignments which will help you towards your course project. That's the plan. And the team, as I said, I'll be teaching the theory. Few classes, probably Ramesh also, I request Ramesh to teach. And Sampada and Nikhil are the MSR students who will be taking most of the labs, and also few 8th semester students who have completed projects with SEVI are also helping me to design the PPT and the presentation. They will be they'll be helping in the labs, but everybody need to do a course project. So the structure of this, I think these are the course outcomes, and most of you are aware that we will come back and see what is Gen AI or generative AI. So the first is you are understanding the fundamental principles and methodologies of Gen AI. Assume at present you know Gen AI, or you will be understanding what is Gen AI, its fundamental principles and methodologies of Gen AI. You will also know how to implement these Gen AI algorithms for different problems, because each one of you are picking a different problem in your course project. So you also, whatever the existing models, how do I, when I propose one Gen AI model, how good is my model? How good is my architecture? What are the metrics with which they are compared? Different. See, there are more than, if you just see the Hugging Face, which is an open source repository of Gen AI models, and it has a few millions of models. So how do I choose which one I want to pick? What are the metrics that I need to understand? So that will be the third. And fourth one is towards more course project. So you will be doing all the methodologies and trying to understand the entire pipeline of data pre-processing. How do I make the data which is suitable for Gen AI for whatever the task that I have done, plus the training. Probably you also propose architecture, train it, and then do the testing or the inferencing part as well. So this is the detailed structure of course content. The first class is which is of 2 hours is more of a overview and evolution. It's a kind of a motivation, why are we doing a Gen AI course. So actual Gen AI starts from chapter 2. I'll start with autoencoders, go to variational autoencoders, GANs and diffusion models, the entire theory, and then so you will be implementing those small bits in the assignment. And training and evaluation, what are the metrics to evaluate these different Gen AI models, that we'll be seeing in the next. Next is a autoregressive model, which are the base or the building blocks of any Gen AI. So we'll talk about different variants of autoregressive and moving average models, and then transformers, which is again a key for any Gen AI. And we will also see what are the large language models, because the transfer, when we talk about all these, and or when you learn the machine learning, most of the time you have done as a image. All CNN, everything that you have done, it's as a image. So we will cover how the text, how the things, what are the major blocks or the fundamental things that you need to know in the LLM, which is also replicated in case of the vision. So that we will be seeing in the last, and then we will have the unit 3 is basically it's more of advanced topics in Gen AI, plus the ethical consideration and responsible AI. So most of you have seen the deep fake and the images, and the people are getting annoyed with the kind of deep fakes. So what are the ethical and responsible consideration that we need to look into when I am generating or when I am arriving at a Gen AI model? So probably that I'll not be able to do it in very detail, but I'll be covering what are the different things that you will be. There are now the standards which are coming for ethical and responsible AI, like the other communication standard or any standard. So standardizing is not an easy job. Standardization is a it's a game. For large number of days, I think still we don't have any standardization for the cable, for your charging cable. Do you have? Do you have? And making it is just a day's job for all the vendors, all the phone vendors. But nobody wants to do that. There is an ROI for them. So standardization is not a very, particularly the de facto standard. De jure standard. What are de facto standard? You will go and buy a Reebok shoes, and then anybody says that why are you buying a Reebok? If you go and Lee shirt or pant, why are you buying them? Because more people use it, it has become a trend. Those are, because everybody is buying, so it's becoming kind of a standard to buy them. Those are referred as what are called de facto standards. De jure standards are by law. They are, you have a traffic rules, they are de jure standards. When you communicate or when you do any Wi-Fi, there is a standard. You cannot use other than that band to transmit any wireless data. So there is a standard for that. So they all are referred as de jure standard. So arriving at de jure standard is not a easy task. So people are now trying to come up with a de jure standards for ethical and particularly for Gen AI. So still it is in the formation stage. We don't know when they will be arrived. Next, so this is a assessment strategy that we have. All activities, each chapter will have a list of activities, that whatever I have shown. So all activities together you have 50, and course project will have a continuous assessment the moment you start the course project, which carries 30, and the final demonstration of the course project will have 20. That is any question so far regarding the assessment method, or you want me to deviate anything from this? This is what we thought it would be good for the assessing the course that we have designed. So very formal. I think today I may not start any of the actual course. I'll just give you the motivation. Why are we studying Gen AI? I don't have to define Gen AI, or you want me to define? I think I have done. So what is Gen AI? Here I have given a big picture. What is AI? What is machine learning? What is deep learning? That's what you have been hearing. And what is Gen AI? This gives. See, when I say these AI, machine learning, deep learning, what for? We want to mimic the human. So human action or decision depends on basically three things, which is called PCA. P is perception. There is a perception. What do you mean by perception? If I see this, I say there is a 3 rows, there are so many people sitting. What I perceive from looking at the scene. Next is a cognition. C is a cognition. What is cognition? I have a mental model of what I perceive. What is the mental model I have? I say that this is a class. There are so many people sitting. I know these 5. I don't know these 15. I have interacted with these 2. Why I do that? Why I do that? I have a learning model in my mind. The cognition requires the prior information regarding the scene, what I have. Whatever I from the perception, whatever the cognition that I do may not be same as you. Isn't it? So when you come and sit and then just check at on the board, you will have your the perception is what? Perception is what you are seeing on the board. But what is the cognition level that you are saying? I have seen this. You are reading that. You are doing some cognition. Is an inference that you are trying to make, which leads to action. Which leads to action. So when I'm saying something, when I see the faces, I feel maybe what I have said by looking at the faces, it's not very clear. I repeat in a different way. That is the action. That action depends on the perception, cognition, which leads to action. Now most of the deep learning models have already perception almost solved criteria or solved thing. Not it never it will be 100%, but it is predominantly it is a why you get so many deep learning algorithms to perceive, to give. When I'm walking, you say that this is a drivable area, or when I'm parking, this is the area that you can park, or if I want to hold this duster, they say this is a liftable area, so that I can, or any robo can come and pick that area. So the perception is almost done thing. So cognition requires what prior knowledge I have in my learning, and people are trying to do that, which leads to action. So most of the time all robotic kind of applications talk about action, and most of the time we work on cognition level. What decision, when I for example, when you are classification, what are you doing? You are making a decision whether it's a cat image or non-cat image. And when I say it is a cat image, where exactly the cat image is coming. So you are doing many level of inferences from that. So what is Gen AI? Already I have given a so it is in the bigger class of AI, which involves many things. Machine learning is a subset of that. Deep learning is still a subset of that. Machine learning, which was existed, which is a classical statistical methods, and deep neural network. See, when these statistical methods started working, when there was a huge amount of data. When the huge amount of data started coming, when there are many cameras across everywhere, your mobile phone, your traffic signal, everywhere you go, the campus itself has more than 100 plus cameras. So you have a huge data. Bottleneck was compute. So the compute also started evolving very much. The data is more, the compute facility is more, then the inference or the making the algorithm work became more realizable, more tractable. So what is the formal definition of Gen AI? It's a type of AI. This is one of them, by the way. So people define it slightly. The philosophy remains same, but they define it slightly in a different way. But it's a type of AI which is capable of generating unseen new data, unseen new content, which nobody has got or nobody has seen. So it can be a text, it can be audio, it can be a video, it can be image, or it can be 3D as well. While doing this, how can it generate on its own? It has to see such examples which are, for example, if I have a ball, when I say generate me a ball of a smaller ball, what do you mean by smaller ball? You have in your mind you have an idea of, when I say ball, you have an idea that there is a radius which is defined. So there is the sphere generated with that radius. When I say smaller ball, in your mind you generate that whatever the ball I have in mind. So I generate, maybe some person will have this as a first initial ball, and maybe one person has this as an initial ball. What you generate? Next level of that. Some person from this to may generate this, some person from this to this. It depends on what you are, and at different instances this may not be the same. This may be very, very different. So Gen AI generates new content, either text, audio, image, video or 3D, based on what it is being exposed to, which are parameterized. Why I am saying which are parameterized? To generate a new data, I need to know some handle which I can vary and generate a new. I'm not saying how part now. I'm saying what. What does it generate? So when you generate a new data, can it generate very different than what it has not seen? Say for example, I think I don't have a slide that if you just check the whatever the AI model which generates a model, the female model or the male model, they have a different hairstyle. In one model, whatever the size of the waist is only only this, which is not actually real. So it depends on how you want to parameterize, what you want to parameterize. Say for example, if I parameterize only hair, what do you call it? Spectacle, hair spectacle, the eye color, the nose shape, the lip shape, and the face skin color. These are only parameters that I have. And the dress, few examples. So if I have only these parameters, I can generate by varying only these parameters. That's what is the Gen AI talks about. The basic building blocks of Gen AI are the autoencoders, variational autoencoders, generative adversarial networks, which is GAN. Most of you already learned this, AE, VAE and GAN in your machine learning course, but probably you will be learning slightly in a different context than the machine learning course. And you also will be learning the ARMA and ARIMA models plus the LLMs. Any questions so far? So here I'm giving a few outcomes of whatever the AI report by Stanford University. Here I am putting a Stanford AI report of 2023. These are the few 10 plus takeaways that the report says. And particularly, most of you know all this. Look at the red that I have. So, first time in the last decade, the investment in AI decreased in 2022. But next report, I think I didn't make this red. Initially I had made, I don't know why it has not. So here, this is the 2024 and look at this. So what it says, investment in AI skyrockets. There is a from 45 to 86, in the range of 45 to 86% increase in the investment, which is very, very huge. So I think I'll scan through or give different perspective. This is how the number of notable machine learning models by the sector over last 10 years. The industry academia, just the academia, the government, industry research and academia government. So if you look into the same AI report, the difference between industry and industry academia is not this huge. If you see, this is a quite heavy. At least few years back, if you see, this is not very so. And look into the what kind of a models depends on. You have a open access models, you have a proprietary models, you have a paid models, that is a proprietary models. How the distribution of these? So this is a look at the open source models. Open source models have grown largely than the proprietary. So why people are taking open source model as a base and building their applications using a open source model. The Hugging Face is the entire open source model. You can, if you generate, you can give back to the Hugging Face. People can use your model if you keep it in the Hugging Face. If we look into the training cost of each of these models over a period, look at the training cost. The cost is in dollars, not in rupees. Look at the cost of training, which is actually very, very huge. We are planning to buy H100. Today we have a meeting which cost 5 crore. One H100 with just 8 GPUs. And NVIDIA person was saying the Microsoft has ordered 3 million GPUs. And Facebook and other people will have their estimate was around 4.5 to 5 million GPUs, but the requirement has more than the double. See, that is the kind of a compute hungry everybody is going. So by looking at this, all companies are going, investment is done, so there would be opportunities for you to position yourself into a good industry and then make a difference of your career as well as to the technology. This is one more. What are the notable machine learning models? The first graph, this one. As per the country. Next is the patents in AI, how they have skyrocketed. See the exponential growth of patents in this. This is the number of patents in AI. This is again number of GitHub projects, which is a source for you to copy and then start your project, which again have the exponential growth. See, this gives you how these models infer on seen and unseen tasks. At the end of the day, what we want to do, we want to make our accuracy for the unseen task, which is more generalizable. So this is the comparison between the seen task, unseen objects, which is average across all of them are average across all. So unseen background, unseen environment, and the total unseen average. So which gives you some tasalli, yes, there is quite a bit room for you to contribute. Next, this is how training compute with collaboration with industry, academia, just industry, academia, government and the researcher across different sectors. Look at the how industry, see if you look into 10 years back, there is no, or if you look into just up to 2017 also, hardly notably there are few industries who were playing the role. But after that, last 6-7 years, it's grown very heavily. This is a notable machine learning models by domain wise. I think probably we will share the link. If you go to that link, actually you can go to the particular model and then you can see the main features of it. Most of you know ChatGPT, Palm, PLM, GPT. At least we have shown Bird. Most of you see already know. How many of you have not used ChatGPT and the Palm or anything? All of you are using it, isn't it? So I need not have to spend much time here. Please, we will share this. Please go and see each one of them separately, so that what are the different models. If you particularly see the kind of industries, the top few industries, and the evolution of those models over a period. By the way, all this is a motivation. Why are you learning? Why you need to learn Gen AI? All these years, we were also learning, not as a very structured course. We wanted to do some research work, so we learned and then started applying. And when we want to teach a course, then it is different. There are no ready books available for this. Whatever the content that we have framed, it is what we thought would be the right content for you to give a learning. So this also gives regarding what is the AI growth. How the AI from 16 billion to 100 plus billion in 1 year, and 2024 forecast is much higher. And if you look into the Gen AI growth, which is much larger. So with this is a growth rate of Gen AI, what people have predicted, which is very huge. Whether you like it or not, you have to be part of either the user of Gen AI or the proposer of solution towards using Gen AI. So if you want to be in the race, or if you want to be in proposer of solution using Gen AI, you have to think. You have to think differently. See where it cannot be used. You have seen how it has become a part and parcel of our life. You cannot think where it cannot be used. You can just think what use cases that I can pick up and demonstrate. There are large opportunities for you to think those use cases and do the course project, which may lead to a good startup. If you pick that kind of a use case which may lead to a good startup, or one of the players may acquire you if you consistently do the better job there. So that's why the startups in AI skyrocketed. It's more exponential growth than any of these. So you have a larger opportunity space for you to contribute. I think I'll quickly scan through this. So what are the different dimensions of that we have? Any DL or any this thing, we have a data, we have an architecture or a model, and we have a output. When you come into, when you look into only the data part, so how the data sets have grown over a period, that is very huge. Then if you look into the that is the more of a NLP data set, this is more of a vision data set. Then if you look into the model, model will again, there are large number of models evolved, and the number of parameters from each model also has grown heavily. And the next is, what is the, no, I think the task, then okay, this is the complexity of tasks. So initially, when Vision, what we did almost 20 years plus, 25 years back, it was a very depth estimation, image super resolution, very, very, very naive tasks. And then came a classification, whether it's a dog image, cat image, then came a localization. If it is a cat image, where exactly is the cat? Then came a object detection and instance segmentation. Then came a semantic segmentation. If I have this has so many number of chairs with writing pad, these many people are occupied, this is not occupied, there is a dais. So there is a kind of a semantic segmentation of a scene. Now with semantic, it is a panoptic segmentation. Each pixel is associated with semantic segmentation. That is the complexity of a task that we are looking at. All this is a part of a perception. We have not yet entered into a cognition. Are you getting? So the key dimensions of trustworthy or the deployment: safety, robustness, explainability, accountability, auditability, environment, privacy and fairness. These are the major 6 dimensions, and there are 3 perspectives: technical, user or social, or people also use ethical AI, beneficial AI, responsible AI. So all these terminology we will see only in the end, once we know what are the how do we build a Gen AI. So this is a pipeline, how exactly the Gen AI. In the entire course you will be studying this only, so no need to give much of attention to this. I think this is not a very clean slide. It just shows how many models are available and they are evolved, and what are the players who are working. Again, this is the evolution of platforms, applications. This is text to image generation, which is I think now everything has become so easy. I think I'll directly skip this and go to play this. Why it is not playing? Why it is not playing? Huh?
There's some issues with it's not natively made in Keynote, so it is
This
iPad does not support PPT. We don't have
Keynote and open ಮಾಡೋಕ್ಕಿತ್ತಲ್ಲ?
Keynote open ಮಾಡಿದ್ವಿ, but the PPT may not support the PPT animations.
Oh, Keynote has copy ಮಾಡಲಿಲ್ಲ ನೀವು. Okay, actually there is a video. The car is actual car, and the car is being environment is replaced with a different context. You can generate a different. You can generate a city. You can generate a thick forest. You can generate a desert. But the road remains the same for the entire whatever the trajectory of the car driving. So you can do many of such things. I think it's doing good. So what needs to be done? It is giving you, depending on whatever the information you give, the text information that these are the few examples that I think it is playing here. It's not playing there. I don't know. Okay, you can generate many of such how the 3D is being generated. So you can change the fabric. I think why it is not getting displayed here. Maybe if you can see here, the garment is been, the color, the texture plus the style is getting changed. Like this is kind of a parameterizing the Gen AI model. I think this also, I don't know whether it plays or not. It's playing? Huh? It's live session is playing. Okay. Okay. I think this is what I wanted to give as a motivation and intro to the Gen AI. So what you learn, how you learn depends on how much time that you want to invest in the learning process. The classes are driven by you. So how much you want to know depends on how you want to drive the class. As I said, please, so remember the car and the ice cream story, and don't keep the question to yourself. Just raise the question. I think I thought of doing both this and the recap of ML. I couldn't do recap of ML. Probably I'll do the recap of ML till autoencoders. Linear and logistic regression probably I'll do, and then autoencoders anyway we will start in detail. Okay, thank you. Now time.